People think they know carbon, but do they really? Carbon can make up so many materials that are found in daily life. Diamond, graphite, graphene, carbon fiber, and then of some obscure things like Buckyballs and carbon nanotubes. All these things are essentially just carbon. The difference is how they're arranged in terms of their crystal structure, which is the placement of atoms. This is a diamond. This is a three-dimensional, accurately placed representation of where the atoms of a diamond would be. All of these black atoms are, all these black spheres are carbon atoms. When you pull back, it looks like this, a diamond. Why is a diamond so hard? Why is it transparent? Why does it reflect light the way that it does? And why do rainbows seemingly get trapped inside? The answer is all in the crystal structure. Diamond is big enough. The spacing between the atoms is both three-dimensional, so that each carbon gets to bond to 4 more carbons, and it forms this three-dimensional lattice. And it's actually big enough that light can pass through the open pathways and it looks transparent. That's the atoms are far enough apart. Whereas if you have graphite, it's actually black or gray. The thing that makes carbon the basis of all life is the same thing that allows it to make even more complex shapes than the three-dimensional shape of a diamond. If you arrange 60 carbon atoms in sort of a soccer ball structure, you end up with this Buckyball, which they discovered, and they've used those in medicine, and I think they're actually found in soot particles. You could also arrange them if you take one of these sheets, one single sheet of graphite, and roll it into a tube, you end up with a carbon nanotube. These are extremely high, great conductors of electricity and heat, and theoretically, if you could grow them long enough, they would be extremely strong. And in fact, they're kind of a wonder material. Speaking of super great conductors made of carbon, if you take one single layer of this multi-layer mixed up graphite and you slide that off somehow, believe it or not, they did it with tape and they actually won the Nobel Prize for that. But you can actually get a single layer of carbon atoms known as graphene. This has a lot of potential for being used in medicine, and you can use it to conduct electricity, and it's, even though it's microscopically thin, it's still going to be very strong. When you take carbon and you make a long chain of this carbon, and sometimes hydrogen and sometimes nitrogen and sometimes oxygen, but mostly carbon and hydrogen, you can make a long chain, and that's actually what's known as a polymer or a plastic. And if you take that polymer or plastic and you heat it up without letting it burn, you can convert it into what's called carbon fiber. Carbon fiber is stronger than steel for its weight, and it's made entirely of carbon, but it's in linear and long chain configurations. You can make many things with it, including bicycles and sports equipment. You can have golf clubs. You could have sailboats made with the hull made out of carbon fiber. It's an amazing material, and it's usually used in conjunction with epoxy as a composite.